In this video, we're going to review some definitions associated with closed curves. First, we say that a curve C is a closed curve if its initial point and its terminal point is the same. For example, a closed curve might look something like this. It might start here with this initial point, travel all around, and eventually come back to its initial point. Next, we say that a curve is simple if it doesn't intersect itself, except maybe at the endpoints. So an example of a simple closed curve might look something like this. Start at one point. As long as it doesn't intersect itself and end at the same point, we have a simple closed curve. We say that a simple closed curve has positive orientation if the region enclosed by the curve stays to the left of it as the curve is traversed. So in our example above, let's call our simple closed curve C. The region enclosed by the curve we'll label as R, so we're looking at this region right here. So now let's try to traverse this curve. Start at the initial point, so imagine yourself walking along this curve. Notice as you go along this curve, your region is always on the left-hand side, and that tells you that your curve has positive orientation. We say that a simple closed curve has negative orientation if the region R stays to the right-hand side of the curve C. For example, let's say I have a curve like this. It starts with this initial point, and this time it goes around clockwise. My region R is this region enclosed. So this time, as I traverse my curve, so start at my initial point and go along the curve, I notice that my region is always on the right-hand side of the curve. So we say that in this example, my curve has negative orientation. So again, when your curve goes counterclockwise, your curve has positive orientation, and when it goes clockwise, it has negative orientation. So one last thing to note is that when we compute line integrals on a simple closed curve with positive orientation, we use the following notation. The line integral, this time we draw a circle around the integral symbol over the curve C of f dot dr. As we've mentioned before, if f is a conservative vector field, then the line integral over a closed curve is going to equal 0. This is because of the fundamental theorem of line integrals. We can evaluate that line integral by taking the difference of the potential function evaluated at the endpoints. And for closed curves, the endpoints are the same, so this difference is 0. What we'll look at in the next videos is how to evaluate this line integral when f is not a conservative vector field.